Chemistry Module, page 97, Natural Rubber. What are natural polymers? Natural polymers are polymers that exist in nature and are non-man-made. What are examples of natural polymers and their monomers? Protein, amino acid, carbohydrate, glucose, natural rubber, isoprene. Explain the structure of natural rubber polymer. Rubber is a natural polymer. It is formed from the monomer isoprene with the molecular formula of isoprene, which is C5H8. Refer to the module for the structural formula. Latex. Latex is a milk-like liquid obtained from tap rubber tree. Latex is a colloid which contains suspension of rubber particles in water. Why latex exists as liquid? The rubber particles are made up of long-chain rubber polymers C5H8 and surrounded by a protein membrane. The protein membrane is negatively charged. The force of repulsion between negatively charged particles prevent them from combining or coagulating. What is coagulation of latex? Latex in liquid state change to semi-solid. What are the causes for coagulation of latex? Latex coagulates when acid is added to it, such as methanoic acid, ethanoic acid, or any other weak acids. 2. Left aside for 1 to 2 days. How latex coagulates when acid is added to it? 1. Positively charged hydrogen ion from the acid neutralize the negative charges on the surface of the protein membrane. A neutral rubber particle is formed. 2. The neutral particles no longer repel each other. These neutral particles collide with each other, causing the membrane to break. 3. The rubber polymers are freed and they coagulate by combining together to form large lump of rubber polymer. The latex has coagulated. How latex coagulate? When latex is left aside for 1 to 2 days. 1. Bacteria from the air enter the latex. 2. Activity of bacteria in the latex produce lactic acid that contains hydrogen ions, which causes coagulation of latex. Coagulated latex is semi-solid. 3. Positively charged hydrogen ions from the acid neutralize the negative charge on the surface of the protein membrane. A neutral rubber particle is formed. 4. The neutral particles no longer repel each other. These neutral particles collide with each other, causing the membrane to break. The rubber polymers are freed and they coagulate by combining together to form large lump of rubber polymer. The latex has coagulated. How to prevent coagulation of latex? Coagulation of latex can be prevented by adding ammonia, alkali, to it. How the presence of alkali can prevent the coagulation process of latex? A. The ammonia solution containing hydroxide ion will neutralize any acid that may be produced by the bacteria. Hydroxide ions from alkali neutralize hydrogen ions produced by acid as a result of bacterial attack on protein. C. The protein membrane remains negatively charged because there is no hydrogen ion. D. The rubber particles repel each other. E. The rubber polymers cannot combine and coagulate. Properties of natural rubber and their uses. Elasticity. When it is stretched, it straightens out. It returns back to its original shape once stretching force is released. Uses: rubber tube, gloves, rubber bands, and shoe soles. Resistant to oxidation. The natural rubber polymers are easily oxidized due to the presence of double bonds. Effect of the heat. When it is heated, it softens and becomes sticky. When it cools, it becomes hard and brittle. Effect of solvent. Natural rubber is soluble in organic, alkaline, and acidic solution. How to improve the properties of natural rubbers? The property of natural rubber can be improved through vulcanization process. Natural rubber becomes stronger and more elastic after vulcanization. How vulcanized rubber is prepared? Sulfur is heated together with natural rubber. Rubber stripe is soaked in sulfur monochloride solution in methyl benzene for a few hours and then dried. Explain how the presence of sulfur atoms change the properties of vulcanized rubber. The sulfur atoms form cross-link between the long rubber molecule. 2. This reduces the ability of the polymers to slide over each other. 3. The rubber molecule return to their original position after being stretched. Compare properties of natural rubber and vulcanized rubber. Elasticity. Natural rubber less elastic because the polymer chain of rubber can slide over one another easily. Vulcanized rubber more elastic because the sulfur cross links prevent the polymer chain of rubber molecule from sliding over one another. Strength and hardness. Natural rubber weaker and softer. When it is stretched beyond the elastic limit, the polymer chain will break. Vulcanized rubber stronger and harder because the presence of sulfur cross links between the polymer. Resistant to heat. Natural rubber cannot withstand high temperature. It is easily melt when heated. Vulcanized rubber can withstand high temperature because the presence of sulfur cross links makes it more difficult to melt. Resistant to oxidation. Natural rubber is easily oxidized by oxygen because the presence of many double bonds in the rubber polymer. Vulcanized rubber is not easily oxidized by oxygen because the number of double bonds is reduced. After finish completing the notes, please do the exercise on page 92, 93, and 94. The answer will be given later.